Hello, let's play some dominoes. We'll solve pips. I'll start with easy. What is going on here? We have a 3 that must have a 1 to point into this 3 region because we have no zeros. So then we'll have a double 1. And then we need, looks like double 6s for the 12, double 4s for the equivalence region, and then we'll finish that with a 4, and that's that. Okay, nice and simple, as is usually the case with the easy. We'll move on to medium. Okay, so can we put the 4 in a single... We could put the 4 with a 4, 0. We also have a double up here, which will need to be the double 3, I think. We have no other possibilities for that. Oh, and we need a 5 equivalence, 5-sized equivalence region. What might that be? That will be... It's zeros, right? It must be. Yeah, I think it is. So... we need a 0 with greater than 4, which looks like it'll have to be the 6. Then we need... Interesting. We don't have a double. Wait, how does this work? Yeah, so we have a 4, so we'll need to make a 4 from 2 halves of the zeros. So it could be 3, 1. Actually, it has to be 3, 1. It can't be 2, 2, because we don't have 2 cases of 0 and 2. No, wait. No, that's not true. Sorry, the thing I just said is not true. How does... No, okay. I feel as though I've done something wrong. How does this work? We don't have any double zeros, so everything in the 0 must jut off from something else. Right, okay. So something juts off from a 4 up here into the blank, and the other one goes into the 0. Sorry about that. Okay. So that means... the 4 must connect to something that doesn't have a 2 in it. So actually, you know what? Sorry, that doesn't have a 0 in it. That means it is going to be the double 2. Sorry, that's the only way that we can make the 4. I now realize, because the other things that come off of the zeros can't be paired with something else. That'll be the other half of the 4. So that's correct. So now we need a 0 going into the less than 3, which will be a 1. And we need to make this equivalence region, which looks like it can only be 4s at this point. And then the other one is just pointing out to nothing. And that's that. Okay, there we go. Got slightly hung up on that, but it was fine. Let's try the hard. Oh, look how small this is. That's very unusual. That's distressing. So we have a greater than 4 going into a 10, and then we have a 5 up here as well. How many 5s do we have? We have 3 possibilities for 5, and they could go into nothing. We also have a 4. We have 2 possibilities of 4. The 4 will go into either nothing or... No, it will go into nothing. The 4 can't point up into the 7, because if it did, we'd sort of break the geometry of the grid. That's interesting. So, what about our greater than 4? Could it be this 5, 4? Then we'd have a 6... yeah, how do we get started on this? This feels like one where maybe we just get started and try things, because everything is just sort of all bunched together down here. I don't... Looks like the 9 might be 6, 3. No, the 7... No, look, the 7 would have to be 6, 1. No, this isn't going to work. Yeah, this is already broken. This is interesting. I'm not really sure how to usefully start this. Now the 7 would have to be 6, 1. Which I don't think is going to work. No, it's not. Okay, I think the interesting thing here is the interplay between the 7 and the 9. We need 16's worth to make those. Is that... That seems to be the thing that keeps breaking, I guess, is what I'm observing here. So what are the ways we could make a 9? we could make a 4, 5, because there has to be an overlap here with something. Do I think the 7 could be... And I guess this could connect this way or this way. We don't know which. It's this 10, 7, and 9 that are all difficult to make work with one another. That's the thing that's tough. So there are 26 between them, which isn't a huge number to make out of 6 domino halves, but it's higher than sort of like the middle. It's higher than average, so to speak. Maybe I should add up all of these things. 10, 15, 19, 26, 37. 37 in these numbered ones. 37, is that what I said? 37, sorry. 15, 19, 26. Oh no, I must have done that wrong. 15, 19, 26 is 35, sorry. Yeah, it's 35 among these numbered ones. 35 plus at least 5 here. So there's at least 40. There's at least 40 we need, not including the blank cells. So 11, 15, 23, 27, 36, 45. 45. Okay, that is actually interesting. That means we can put no more than 5 in the blank cells. We can never put more than a total of 5 in the blank cells. That's actually very interesting. That means we need a blank one in the blank cell. That's not surprising. That's obviously true, because the blank one can't go in any of these. I mean, that's straightforward. But I think what it means is we need a blank, a 3, and a 1. I think that's the only way to limit those to 5. No, we could do a blank, a 4, and a 1 in theory. If we did a blank, a 4, and a 1, we'd have exactly the minimum count we need, which would mean greater than 4 would need to be exactly 5. I wonder if we can disprove that or prove it at the same time. That would mean, so blank, 4, and 1 would need to go. So 1, where would the 1 go in that case? It could, I mean, I don't know, it could go here in theory. 4, 5, then we could put a blank one down here. No, we've already used our 4s. That doesn't work. So the blank cells are either blank 3, 1 or blank 4, 1. That's all they can be. Maybe they are 3s, because I do find 3s have been difficult to get into these bits. I'm not sure. I'm not really sure how to think about this well. So if it were blank 3, 1, the greater than 4 would need to be 6, not 5. That's interesting. And it couldn't be the 6, 3, because then we couldn't make the 10. It would have to be the 6, 5. And then there'd have to be a 5 also here. Interesting. Then we need another 5 here. Oh, that worked. Oh, that worked. Huh, okay. Yeah, so that sort of mathematical approach was actually helpful for me this time. So it was the 3, 0, 1. Yeah. So I knew that based on the counts, the empty cells would need to add up to either 4 or 5. And, whichever of them they did add up to would correspond with whatever went in the greater than 4. So either it was either going to be there, they add up to 4 extras plus 6, or they add up to 5 extras plus 5 in the greater than 4. Yeah, that was interesting. That did help. Okay, that was the pips. Back tomorrow. Bye for now.